Hi, welcome to Learning Monkey. I am Raghu here. In this class, we do some gate bits. For better understanding, please watch our concept videos and come back here. The link for the playlist is provided in the description below. Coming to today's bits, this is given in GATE 2006. Consider the following statements about the context-free grammar. They have given some grammar, context-free grammar. S tends to SS, S tends to AB, S tends to BR, S tends to epsilon. So from these three statements, we can say that S is deriving AB, S is deriving or BA or epsilon. And the statement S tends to SS. From this, we have to understand that S tends to SS, S tends to SS, S tends to SS means we can repeat S any number of times. Means what's the language that it is going to generate? We can generate AB, BA, AB, BA, 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 AB. Anything you can generate means AB or BA whole star, because we can repeat this. AB or BA whole star, that is the language it is going to generate. This language is very simple as regular language. AB or BA whole star means. So from that, now we can solve this bit easily. If you understand the grammar and what's the language it is going to generate, we can easily solve the bit. G is ambiguous. Is it true or false? Yes, G is ambiguous. We have to prove that it is ambiguous by saying that AB, AB, AB. This can be derived using these two different ways. Either this or this. More than one derivative means, derivative tree means it's ambiguous. Yes, it is ambiguous. The first statement is true. G produces all strings with equal number of A's and B's. AB, BA, AB, BA. Yes, it is going to generate the strings that are present in this language are having equal number of A's and B's. But it is not going to generate all the strings that are possibly having equal number of A's and B's. One of the example is AA, BA. BB. This string is having a equal number of A's and B's, but it is not going to generate using this context-free grammar. That's why the second statement is false. The third statement is G can be accepted by a deterministic push-down automata. Yes, we can construct a deterministic push-down automata for the language because it is a simple regular language A, B or B a whole star. So the statement is first one and third one is correct. In our options, we are having 1 and 3 is only. That's the correct statements. So answer is B. Now coming to the next one, GATE 2008. Which of the following statements are true? They have given some statements. The first statement is every left recursive grammar can be converted to a right recursive grammar and vice versa. We already discussed how to convert the given left recursion, eliminating of left recursive grammar. So the same way we can do the right to left also. So this statement is correct, ever left recursive grammar and vice versa. Next one is all epsilon productions can be removed from any context-free grammar by suitable transformations. No, this is not possible. We had shown an example. If the language itself consists of epsilon, we cannot eliminate epsilon from that. The starting production will have epsilon because the language itself is accepting epsilon. Then we cannot eliminate epsilon. So this statement is wrong. These examples we already discussed in the eliminating epsilon production examples. The language generated by a context-free grammar, all of whose productions are of the form X tends to W or X tends to WY, where W is a string of terminals, means W means a string of terminals, or Y means non-terminal. This is similar to right linear grammar, so is always a regular grammar. Yes, it is a regular grammar. The language generated, yes, it is a regular language. So we accept that this statement is also true statement. The next one is the derivation trees of strings generated by the context-free grammar in Chomsky normal form are always binary trees. What's Chomsky normal form conditions? Either Chomsky normal form production conditions are X tends to, you should have two non-terminals or single terminal. Means if you elaborate, if you do the derivation tree for Chomsky normal form CFG, either you can go with two non-terminals or single terminal. Two non-terminals means always it is a binary tree. You can generate only two. So that's why this statement is correct. So what's the statements that are correct? First one is correct, third one is correct, fourth one is correct. From the options it was given that first, third and fourth, option C is the correct answer. Option C is the correct answer. Hope you understand these questions. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.